Imagine you're driving to work, you glance at your speedometer. It reads 40 miles per hour. This simple act, so commonplace in our daily lives, is a gateway to the world of calculus. Calculus is the language of motion and change, and it underpins our understanding of everything from the car you drive to the stars that light up our night sky. Now imagine wanting to know not just your speed at a single moment, but how far you'll travel over the entire trip. Or perhaps you're interested in how your speed changes as you navigate traffic lights and highway ramps. These questions take us beyond the realm of basic algebra and into the fascinating world of calculus. Calculus provides the tools to dissect motion and change with incredible precision. It allows us to analyze things that are in a constant state of flux, like the speed of your car or the trajectory of a rocket. This branch of mathematics is divided into two main areas: differentiation and integration. Just like the two sides of a coin, differentiation and integration offer complementary perspectives on the nature of change. They are the yin and yang of calculus, two sides of the same mathematical coin, and they are essential for understanding the universe and everything in it. Let's return to your morning commute. Your speedometer doesn't just tell you your speed, it hints at the concept of differentiation. Differentiation is about understanding instantaneous rates of change. Think of it like this: if you were to plot your speed on a graph over time, the slope of the line at any given point would represent your acceleration at that exact moment. That's what differentiation allows us to calculate: the precise rate of change at any instant. In simpler terms, differentiation is like looking at a speedometer needle instead of the odometer. It's about understanding how fast something is changing right now, not over a period of time. It's the mathematical equivalent of a snapshot of motion. This concept, as simple as it might sound, has profound implications. It allows engineers to design safer cars, physicists to understand the motion of particles, and economists to model market fluctuations. Differentiation is a fundamental tool that empowers us to analyze and predict the behavior of systems in constant flux. While differentiation focuses on the instantaneous rate of change, integration takes a different approach. Integration is all about accumulation. It's like looking at the odometer at the end of your trip to see the total distance covered. Imagine you're on a road trip. Your speed constantly changes as you navigate hills, traffic, and open highways. Integration allows you to add up all those tiny distances covered at varying speeds to calculate the total distance traveled. It's about summing up infinitesimal changes over time to understand the bigger picture. But integration is much more than just calculating distances. It allows us to determine the area under a curve, which has applications in fields as diverse as calculating the volume of irregular objects, predicting population growth, and even understanding the distribution of heat within a material. Integration, like its counterpart differentiation, is a cornerstone of calculus. It provides the tools to understand how infinitesimal changes accumulate over time to create large-scale effects. It's a powerful tool for understanding the interconnectedness of change and accumulation in our world. The roar of a rocket launched the thrilling descent of a roller coaster, the elegant arch of a suspension bridge. These feats of engineering are all governed by the principles of calculus. Calculus is the bedrock of physics and engineering, providing the language to describe motion, forces, and energy. Consider the immense power needed to propel a rocket into space. Calculus helps engineers calculate the precise thrust required, taking into account factors like gravity, air resistance, and the changing mass of the rocket as it burns fuel. It's a delicate dance of forces, meticulously choreographed using the language of calculus. From the design of skyscrapers that can withstand hurricane-force winds to the intricate circuitry of your smartphone, calculus is the invisible hand guiding the creation of our modern world. It allows us to push the boundaries of what's possible, building structures that reach for the sky and technologies that connect us across continents.